All right, hello everyone. Welcome to our last lesson in the Completing the Square section of lesson unit 1.5. Here we're going to learn about writing quadratic expressions in vertex form. If you have been following along with lessons 9, 10, and 11 so far, this actually is probably going to be one of the easier tasks that we do, as long as we now understand the whole completing the square process. So let's go ahead and get started. Okay, so first, a little bit about what we're planning on doing here. So up until this point, we have learned a lot about different things that you can do with each expression. So for example, in order to write an expression in factored form, we use a factoring process, right? So if we wanted to do, say, if we had, say, in x squared plus 6x plus 8, and we wanted to write it in factored form, we would use factoring. If we wanted to go backwards and go from factored form to regular standard form, we would use distribution. If we wanted to go from, say, vertex form back to standard form, that's also distribution. If we wanted to go from vertex form, excuse me, into factored form, what you would have to do is you would distribute it first and then refactor it. So we can totally do all that, right? The only issue that we have is how do we get it directly into vertex form? How do we get to vertex form, right? So the way that we currently know how to do it is to take the factored form and we can find the axis of symmetry, which is halfway in between the two roots, right? And so if we know that the roots are, -2 and -4, we find the average of that, and that's -3. And then we can write that, use that information in order to help get vertex form. But that's kind of a long way around. Turns out there's an easier way that we can come up with that, excuse me, based on standard form. So our goal here in this unit is to go from standard form directly to vertex form using the process that we now know is completing the square. So let's go ahead and do that. But remember that the whole reason for coming up with that is so that we have an easy way of attaining all of this information from any parabola that we wish. So for instance, if I wanted to find the vertex of this parabola, clearly we use vertex form, right? What's the vertex of that parabola? -3, -1. Remember that the x-coordinate is opposite sign from what's in the parentheses. And so we use vertex form for that. What about the x-intercepts? Well, that's not going to be easily found from standard form or from vertex form. We use intercept form for that. X equals -2 or x equals -4. And the parabola is going to cross the x-axis at those points. How about the y-intercept? Not as easily found from these forms, but the y-intercept is going to be 8. Standard form does the best at that because the 8 is just given to you right at the end of the equation. Now, could you get that from factored form by doing 2 times 4? Yes, but that doesn't always work when you have numbers in front of the x's. So we do have to keep in mind that. When you have vertex form, again, we can think about it that way. 3 squared is 9, 9 minus 1 is 8. And so we do get that as well. As usual, all bets are off when you have a number in front of the, like if we had a 3, let's say, in front of vertex form as a scale factor, then we'd have to make sure to multiply by 3. Standard form, we don't have to worry about that. The y-intercept is just the number that's on the end, right? And that's because when you plug 0 in for x, you get 0 plus 0 plus whatever number is left on the end. Okay. Now with that, actually, you can draw a pretty complete picture of a parabola if you wished. Just giving a quick sketch here, you could go 8 units up. We'll just kind of estimate 8 units up. There's your y-intercept. you could go about 2 and 4, say like that, -2, -4. And then your vertex is -3, -1. And so maybe you have a parabola that kind of does that. So you can use this information to get a very quick sketch of a parabola so that, you don't always have to rely on decimals. Okay. So here are two expressions in vertex form, and let's write them into standard form, right? So if we write them into standard form, remember that we're going to have to do some multiplying here, right? So we have x plus 5 times x plus 5 plus 1. And then for this one, we're going to get, let's see, x squared plus 10x, right? Because you get 5x and 5x, 5 plus 1. And so 25 plus 1 is 26. Let's do the same thing for the bottom one. We have x minus 3 times x minus 3, right? Minus 7. So what do we get? We get our x squared. Now -3x, -3x, that's -6x. Now -3 times -3, that's -9. Or no, +9. Almost caught myself there. 9 minus 7 is 2. And so we do get a 2 there. Interesting. Okay. So now let's think about what's going to happen from here. How could we go backwards? Could we figure out a way to go backwards from standard form into vertex form? Well, let's think about this, right? How did we get to these numbers? 5 plus 5 gave us 10. -3 and -3 gave us -6, right? So cutting that middle term in half might have something to do with it. Okay. Now, if you followed along with our completing the square steps, you realize that is completing the square. And now let's look at the last number, the 26. So that 26 is one more than 25. Now, 25 is the number that completes the square, right? Because 5 times 5 is 25. And so if we knew that 26 was one more than 25, sorry for the bell, then from there we could then think about, oh, if it's one more than a perfect square, then it looks like we have a y-coordinate of 1. Same thing for this one here. Normally, if this were a perfect square, it'd be x squared minus 6x plus 9, because -3 times -3 is 9. But it's a 2. We're 7 units lower than we should be. That's where the -7 comes from. So we have a connection here, but let's see if we can kind of put this into algebra. Okay, let's take a look. So let's think about the term x squared plus 10x plus 9. Now let's see if we can write it in vertex form. Well, let's see. Here's how it's basically going to work. What we want to do is we want to complete the square on here in order to create that x plus something squared term. We know it's going to involve a 5 because 10 divided by 2 is 5. So the problem, though, is unlike the previous equations, where we could complete the square by adding a number to both sides, we don't have an equal sign in this case. So how do we do it? We can't, add 25 to both sides. So this is how we're going to do it. I'm going to start by taking my expression, and I'm going to create the blank anyway. Normally, we would subtract 9 to the other side and leave a blank to add a perfect square. We can't subtract the 9 here. There's nowhere to subtract the 9 to. So what I'm going to do is I'm going to say x squared plus 10x plus blank plus 9. Now, if I add a number and I don't have a second side to add it to. And I want you to think about a balance scale, for instance. If you had a scale and you wanted to keep it the same weight and you added one weight onto it, how would you keep the scale balanced? You'd have to take another weight off. And so I'm going to subtract. I'll highlight this in red. I'm going to subtract a number as well. So by putting down the number that I need to add here, I'm going to also subtract it at the same time. This is different than the previous problems. And again, it's because there's no equal sign. So instead of adding both times, we have to add and subtract. So again, half of 10 is 5. 5 squared is 25. I'm going to add 25, but then I'm going to subtract 25 here. And again, that keeps the equation the same value, but creates this 25 term that I can use to complete the square. So now, how does this get written? We know that this part, the first three terms, there's now my perfect square. And so it becomes x plus 5 squared. Now over here, 9 minus 25, 14? No, 16. That becomes 16. And so we have x plus 5 squared minus 16, and that is vertex form. So the idea here is we add the perfect square, but then we subtract it in the same line. That keeps the equation having the same value. The 25 has the effect of shifting the parabola up by 25 units, and then the minus 25 shifts it back down again. But what that does is it creates the 25 that we can use to write the perfect square. Okay? And you can show this by graphing it. If we were to graph these two expressions, you would find that they have exactly the same value. And they are the same parabola. Okay. So let's continue. Here's another interesting way, type of expression that we can use. So in this particular case, now notice you have a number in front of the x squared. And you might wonder, well, what happens in that case? Well, just like before, when we complete the square, then there's a number in front of the x squared. We have to divide by that in order to move it. Remember that completing the square, and here's a little side note. Completing the square only works using the half the middle term square when a equals 1. And that means you have an x squared term instead of a 3x squared, let's say, i.e. 1x squared. Okay, so that's why the first step that they do is they factored out a 3. Okay, so think of this almost like a proof, if you will. Okay, now the next few steps are the whole completing the square part, right? So we know that, oh, here's something interesting. They add 1 and subtract 1. So why did they add 1? They added 1, and the reason for it is so that the 3 plus 1 creates the 4, because the 4 is the perfect square. This is just another way that you could do it. So adding 1 to create perfect square, and then subtracting 1 to balance. This is another way to look at it. I'm a little bit more preferable to the first way of just adding the 4 and subtracting the 4, but you could do this either way. So whether you add a number to make a 4, or whether or not, or you just add the 4 and subtract the 4, you actually get the same answer either way. But what's most important is what happens at the end. Once they complete the square here, and you've got x plus 2 squared minus 1, notice what happens here is that they re-multiply by 3. And that's because we factored out the 3 originally, so now we have to put it back in the expression. And notice that both terms definitely multiply by 3. Okay? So here's some other questions that you can ask. So what's the vertex of the graph? Well, now we know what the vertex is. -2, -3. Remember, the scale factor does not affect the vertex, the location of the vertex as well. All that scale factor does is say how far the parabola opens. Does it open upward or downward? You should know it's up because the number is positive at the start. The 3 itself is positive. Okay, so here's a couple examples that we can use to write it in vertex form. So we'll just go over 1 or 2 of these real quick, and I would probably, just for the purposes of this, don't have to go over every single question, but definitely let's look at A, right? I think A is a great one. It kind of illustrates the whole process start to finish. So you have -2x² minus 4x plus 6. Remember, completing the square only works when you have x² by itself. So the first thing I'm going to do is divide out a -2. And so we do that, and now I have x². Now, -4 divided by -2 is positive 2x minus 3. And so, yes, 6 divided by -2 is -3. Now we're going to complete the square from here. Don't be tempted to factor this. It is factorable, but don't do it. Instead, we're going to complete the square. So if you think about this, what number would complete the square here? So -2 x² plus 2x plus blank minus 3 minus blank. That's the way I like to do this problem. Okay, so now that we have this, okay, so half of 2 is 1, right? And so what we're going to have is 1 squared being 1. So I'm going to add 1 and then subtract 1. Again, that keeps the equation balanced. If I add 1, I subtract 1 to balance it. Again, there's no equal sign here. So what does this look like? The first 3 terms, x plus 1 squared. Now let's look at the other 2 terms. You have a -3 and a -1. We're going to combine those together, and they're going to produce a -4. So now we have in vertex form, except last step that I have to do, that -2 is still chilling on the outside. I'm going to multiply that back in. So my final answer is going to be -2 x plus 1 squared plus 8. And again, the -8 now, or +8, I should say, is because we multiplied by -2. So now my vertex is at -1, +8. Okay. So that works the same for all other ones like that. Works the same for B and works the same for C. Okay. So quickly, let's take a look. Might as well pick one to do here. Now, the lovely part is if you don't have the number in front of the x², then you don't have to worry about it. That's kind of nice. One more time here. Let's do part B. Okay. So part B, we're going to do the same thing. And you have 4x². Let's divide by 4. So we have 4 parentheses x² plus 6x plus 5. We've divided all the numbers by 4. Okay, and that 4 we're going to keep on the outside. Again, it doesn't disappear. We'll just keep it there. All right, let's create a space here. x² plus 6x plus blank plus 5 plus blank. So what number completes the square? Half of 6 is 3. 3 squared is 9. Add 9, subtract 9. So I have x plus 3 squared. That's why I always write down that 3 first, even though it's not part of the original expression, but it does come back when you factor it, okay? And then, so the first 3 terms, there's your x² plus 6x plus 9, that's x plus 3 squared. 5 minus 9, that's -4. Once you have that, Now this whole thing is going to get multiplied by 4. And so my final answer becomes 4x plus 3 squared minus 16. And there we go. Now it's in vertex form. Again, if there's no number in front of the x squared at the beginning, we don't have to worry about it. Okay. And hey, I'll leave part C. You could either work on it, we'll work on it in class, or leave you as an exercise to the reader. And you could see how if you could do that one. And I'm considering that expression myself. Again, minus 20. So it looks like this expression is going to end up being, if I had to look at it, this looks like it's going to be negative x minus 10 squared minus 100. I believe it actually changes to positive 100. Yeah, that should be correct then. And I'm looking to see where the vertex is. So the vertex should be at 10, 100. And so that certainly looks like that would work here, because if I put 10 in for x, we get negative 100 plus 200, which is 100. So that is certainly the vertex form. You can check your work there. Go ahead and do that one, see if you get that answer. If you do, you're probably well on your way. Okay, so that's basically it. Here's a quick little summary for you. There's a couple different ways that you can do this. Method number 1 is you can just simply add the correct perfect square and subtract the correct perfect square. Or you can add and subtract the number that makes the perfect square. So here, either way works. You can do plus 1 minus 1 or plus 25 minus 25 in order to create that 25 term that completes the square. Either way certainly works here. The choice is yours. All right. Okay, that's a nice little video just illustrating this process, and that's the rest of our completing the square unit. So hope you had fun. I certainly have fun making these videos. Don't forget to hit that subscribe button for more video smash from Mr. Melillo. All right, have yourselves a great day.